So today's we are going to discuss about the concept of the matter class. In the last class, we already discussed about the classification of matter on the basis of physical property. So in this class, we are going to discuss about the further classification of matters. So matters are classified into mixtures and next second one is pure substance. So what is mean by mixtures? We will study that mixture, what is mixture in detail in next uh, further. So we will study very briefly about what is mixture. So mixture means two or more pure substance may be present in any ratio. For example, sugar solution. For example, sugar solution we call as a mixture. Mixture or solution which are made up of pure substance. For example, sugar and water. We are adding sugar in the water in any ratio. There will be a no definite, we have to add this much quantity. There is no fixed, any ratio we can add. That kind of solution we called as a mixture, for example, and there will be no participation of any chemical reaction in that mixture. There is no involve any chemical reactions. So further, mixtures are classified into two types. One is homogeneous mixture, another one is heterogeneous mixture. What is mean by homogeneous mixture? Homogeneous mixture and heterogeneous mixture we will discuss. And further, second, pure substance. In pure substance, uh, they are classified into two types: elements and components. These are the classification of matter. First, matter get classified into two types: mixtures and pure substance. And in further classification of mixture, get classified into homogeneous mixture and heterogeneous mixture. For homogeneous mixture, so sugar mixed with water is one of the example. For heterogeneous mixture, mixture of salt and sugar. For pure substance, they are classified into two types. They are further classified into two types: elements and the components. Next, we are going to discuss about the mixtures. The in the chemistry, when two in chemistry when two or more substances mix with each other without participating in any chemical changes, the resulting substance is called mixtures. Whenever we are mixing any substance, for example, we are taking sugar solution in water. When we are mixing sugar in the water, there will be no chemical changes. We should not see any chemical changes when we are mixing sugar solution in the water. Sugar in the water, there is a no change in any chemical changes. There is a no chemical reaction will be not take place when we are mixing the solution. As a resulting substance, what is we get resulting substance is sugar solution. That solution we call as a mixture. So some of the properties, like the components of the mixture each kept their original properties. For example, sugar solution. In sugar solution, what are the components we are using? Sugar and the solution. When we are mixing sugar in the solution, there should be no change in the sugar and water. There is a no change in the sugar and water. Its property should be remains same when we are preparing a solution, a mixture of sugar solution. Second is the separation of the components can be easily done. In the mixture, we can separate the components, what for sugar and solution. If we want to separate sugar and solution, simply we are going to heat that solution, we will get sugar. We can easily separate the components. And next, proportion or ratio of the components is variable. We are not fixing any ratio to add. For example, we are taking ratio of 1, and the water, so water has 2. We can change any ratio. We can change 3, 4, like there is a no fixed ratio while mixing the while preparing the mixture. So these are the properties. For example, a very good example is sugar solution in water and air, etc. In this simple way, mixtures are the mixtures when we are adding where when the components are adding to prepare a mixture, there should be no chemical reaction take place. And also chemical reactions and the whatever the components we are using to prepare the mixture, the components there will be no change its properties. So third one, we can easily separate those mixtures. So in the we already study about the mixture. The further classification of mixture is homogeneous mixtures and heterogeneous mixture. The best example for homogeneous mixture is sugar mixture. This is one of the best example for the sugar mixed with water. Sugar solution is one of the best example for homogeneous mixture. We will see what is the actual meaning of homogeneous mixture. The compounds completely mix with each other. This means the particles of the components of the mixtures are uniformly distributed throughout the bulk of a mixture, and its composition are uniform throughout. Composition are uniform throughout. What is mean by when, for example, sugar solution? In sugar solution, the sugar and the water are the two components. The sugar and the components are mixed very uniformly throughout the solution. The mixture of the components in the homogeneous mixture is the components are mixed uniformly throughout the bulk of the solution. Compared to heterogeneous mixture, opposite, here uniformly distributed distribution of the component take place, but in heterogeneous mixture there is a ununiform, not uniformly distribution of the component take place. The best example for the heterogeneous mixture is mixture of salt and the sugar. Salt and the sugar is the one of the best example, and sometimes different components are visible. For example, salt and sugar we mix, but components we can visible. But in the sugar solution, the components are not visible. We can't see the sugar in the water after mixing, because in the homogeneous the mixture of the component take place very uniformly distribution, very uniform way it distribute throughout the bulk of the solution. But in the heterogeneous there is a no uniform. And one more thing is, in homogeneous mixture we can't separate by physical method. Physical method means by picking. For example, in the mixture of salt and sugar, we can salt and sugar, or another example of heterogeneous mixture like mixture of sand and stone. We can easily pick the sand or stone from that solution. We can separate, but in the case of homogeneous mixture, we can't separate by easily by picking or any physical method. So these are the two example of the these are the two classifications between the homogeneous and the heterogeneous mixture. So homogeneous mixture, in the homogeneous mixture, we already studied that the components in the homogeneous mixture are uniformly composition. Here the distribution of the components are uniform take place, but in heterogeneous it's opposite, non-uniform composition. So second, it cannot be separated out physically. So in homogeneous, we already know that we cannot separate the solution by physical method. But in heterogeneous mixture, we can easily separate the components by physical method. How? By hand picking, filtration, and distillation, etc. So in this homogeneous, homo means same. In heterogeneous, hetero means different. One more example for homogeneous mixture is alcohol in water, and example of heterogeneous mixture, mixture of sand and water. One of the example. These are the some difference between the homogeneous and heterogeneous. About the classification of the matter into two types. One is mixture and one is a pure substance. The mixture is further classified into homogeneous mixtures and the heterogeneous mixture. We already discussed the difference and what is the mean by homogeneous mixture and heterogeneous mixture. So in this we are going to discuss about what is pure substance. The constituent particles of a pure substance have fixed composition. In the mixture we know that the composition of the mixtures there is a no fixed ratio. We study that there is a no fixed ratio for the mixture, but in the pure substance there is a fixed ratio. For example, we will take the best example as water. Here, water molecular formula is H2O. So, to form a water, we require two hydrogen and one oxygen. Here, the ratio is 2 is to 1 hydrogen oxygen. This is the fixed ratio. We can't change this like 3 or 4. We will not get this water. So what is mean by pure substance means in the pure substance, there is a fixed composition. There will be no changes in the composition. For example, water. And we also take the example of glucose glucose containing carbon, hydrogen, oxygen in a fixed ratio. So this is mean by pure substance. So pure substance is further classified into as elements. What is mean by elements? We already know a particle of the particle of elements consist only one type of atom. Only one type of atom. That kind of substance we call as the elements. For example, oxygen. Oxygen has O2. Here we can see that there is only one type of atom. So one type of atom. This type of substance is called the elements. So in this video we discussed about the further classification of the mixtures. The mixtures are classified into matters are classified into two types, mixtures and the one more is pure substance, the mixtures, and further classified into homogeneous mixtures and heterogeneous mixtures. We all study what is my homogeneous mixture and heterogeneous mixtures, and we also studied about the difference between the homogeneous mixtures. And one more classification is pure substance. What is meant by pure substance, and the pure substance is further classified into elements. So thank you for watching this video. Thank you.